Oh my goodness. Thank you very much for letting me know, because when I set it up to record automatically, but I'm having problems with it. Thank you guys for letting me know. Very good. Now let us proceed. Another scenario would be a box here is 0, this one, and then a leading here, a star, 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 star. So there are a lot of scenarios to be able to create the echelon form. Now, today what we're going to be start talking about basically is how to solve a system. So granted I have no problem with the internet today, we have to learn how to solve the system. So I start with how we're going to proceed, and then we proceed. What's going to be the idea about solving a system? We usually will start with the system, whatever it is. And then we're going to associate to it the augmented matrix. Then we perform operation on the augmented. We perform row operation. The row operation do not change the solution of the system. Once the augmented will have the echelon form, then we will write the system that corresponds to the echelon form. And we solve right there. Because once we have the system, once the augmented is in echelon form, and then we can do a back substitution. Sometimes we will stop at the reduced echelon form, and I will explain very clearly today what's the difference between both of them. So let us start solving system. So I will solve a lot of system today. I start with the system. So I need to find the values of x1, x2, and x3 that satisfy those three equations. Okay, so step number 1 is immediately we write the augmented matrix that correspond to my system. That's my augmented matrix. And then we need to perform a row operation using the algorithm to reduce this matrix to its echelon form. So let us perform those row operations. Right. So whenever I produce a row operation, I create a leading here. My leading is right there. So it's a 1, 1, minus 1 is 2. And then I use this leading to create a 0 under it. And to be able to do that, we do replacement. So I'm going to take the first row, multiply it by a negative, add it to the second row, and this with me, and I replace the second row by the resulting object. And this will become my new row 2. The idea here is basically to get rid of the coefficient of x1. So minus 1 plus 1 is a 0, minus 1 plus 2, it's a 1, minus minus, it's a 1, minus 3, it's a minus 2, and then minus 2 plus 0, it's a minus 2. All right. Today I will do 2 operations at once. In other words, that last time I wrote the third row, and then I did minus 2 plus 2. So today, because you should have practiced this, I will do 2 operations. So I'm going to use this row to make this into a 0, and I'm going to use it to make this into a 0. So the other operation I will do is minus 2 row 1 plus row 3, and this will become my new R3. So replacement, replacement. Minus 2 plus 2, this gives me a 0. Minus 2 plus 1, it's a minus 1. Minus minus, it's a 1, 2 plus 6, it's an 8. And minus 4, it is a 20. Leading, everything below a 0, right bottom. I create a leading, I have it, and I use it to make this into a 0. So it means now the operation I use is I take the second row, and I only have to add it in this scenario. So I'll just have to add it. So plus row 3, and this would become my new row 3. So it's a 1, minus 1, 2, 0, 1, minus 2, and it's a minus 2, 0. 1 minus 1 is a 0, minus 2 plus 4, that's a 4, minus 2 plus that, Is there any mistake? Okay. All right.
Wait.
Go ahead.
Shouldn't it be 6,
Where?
19,
6.
This one?
negative 2 plus 8?
Which row, which column?
For the 4 instead of the 4, shouldn't it be a 6?
Okay, minus, sorry, minus 2 plus 8, it's a 6. My apology, I got frustrated because we got into, and then minus 2, and that's 18, correct. Now, I stop when I reach the echelon 4. 1, 1, and 1. I am in echelon 4, I can stop. And then what do I do immediately? We write the system that corresponds to the echelon 4. So what's the system? The last one, 16x3 equal to 8. The one before it, x1 minus 2xt equal minus 2. And the first row is x1 plus x2 minus x3 equal to 2. When we hit the echelon 4, it means the system is ready to be kind of solved. So I write the system, and now we will use what we did last time and call back substitution.
Excuse me, for the system, for the second line, shouldn't it be x2 minus 2x3?
Very good. Thank you very much. All right. So now let us solve. Okay. Back substitution give me x3 equal 18 over 6, x3 equal to 3. True or false? Now, what about the second one? I have x2 minus 2x3 equal minus 2. I will use that to solve for x2. So what is my x2? Minus 2 plus 2x3, which is 6. x2 should be equal to 4. Back substitution. So this will give me the second. Now I back up. I know x2, I know x3, I want x1. So now x1 plus x2 minus x3 equal to 2, and this would give me x1. So that's it, 2 minus x2 plus x3. So this would give me what for x1? 2 minus 4, that's a minus 2, minus 2 plus 3, minus 2 plus 3, which give me a 1. So my solution now, 1 for x1, 4 for x2, and 3 for x3. Now, if I go back and substitute in here, in the original system, every one of them has to be satisfied. Every one of them has to be satisfied. The idea is the row operation do not change the solution. What the row operation do for us is to create a system that's much easier to solve. So that's the principle we're going to be based on today, and we're going to do a lot of problem, of course, different, but that to learn how to solve a system. So augmented, echelon 4, stop, back substitute. Very good. Example number 2. We're going to take the following example. Again, we have to solve this one. So the process is always the same. I start with the augmented, and then I do echelon 4. And this is probably the last echelon form I will do. After that, I stop doing echelon form. I'll just give it to you. So again, let's do that. That's a 1 in here. I use it to create 0. So I'm going to take minus the first row plus the second. And this will become my new second row. So this is a 1, minus 1, and a 2. Minus 1 plus 1 is 0. Minus 1 plus 2 is a 1. Minus is a 1 minus 3 minus 2, and a minus 2. Now I need to create a 0 here. I'll take minus 2 first row plus the third, and this would be my new row 3. Very good. Minus 2 plus 2 is 0. Minus 2 plus 3, that's a 1. Minus 2, sorry. Minus 2 plus 2, minus 2 plus 3. Minus 2, 2 minus 4, that's a minus 2. And then minus 2 plus 1, minus 2 plus 1, which is give me a minus 1. Very good. Leading here.
I think it should be a -3 for the last one because we're multiplying the first row by 2.
Yep. I don't really argue when you guys are telling me something correct. And this is the one. Now I use it to create a 0 down here. So what do I need? Minus the second row. I add it to the third. And this will be my new row 3. Please correct me if I do any arithmetic mistakes. That's the only problem I usually have in this course. 1, 1, minus 2, minus 2. So that's my 1. That's now. Take this row and add it. Minus 0 plus 0, that's a 0. Minus 1 plus 1, that's a 0. Minus 2, minus 2, that's a 0. Minus 2, okay, so it's going to give me a 2, minus 3, that's a minus 1. Now, I stop when my matrix is in echelon form. Is my matrix in echelon form here? Yes or not? Is it in echelon form? Every leading is to the right of the leading before it. Everything below a leading is 0. And so this is in echelon form. I stop and I write the system that corresponds to it. That will be always our logic. So what's the system that corresponds to it? And immediately I know that the light bulb is coming to your mind. I'm aware of that. So that would give me the following. Equal to 2, x1 minus 2x3 equal minus 2. And now what about the last equation? What does this equation read? 0x1 plus 0x2, so I write exactly what it reads, plus 0x2 plus 0x3, that's exactly what it reads, equal to minus 1. Or 0 equal to minus 1. What does this mean as far as the system is concerned? So I try to find all the numbers that satisfy this equation and this equation and this equation. So if I try to find them, then I realize this is going to lead me to a statement which is a nonsensical statement. So I have 0 equal minus 1, which really doesn't make sense. What this tells us that the system is inconsistent. It means there is no solution to the system. Inconsistent. It means no values of x1, x2, x3 can satisfy all the 3 equations. So every time we are solving a system, and this can occur, and we end up is a row in the echelon form that read 0 equal a non-zero number, it means we have an inconsistent system. It means a system that has no solution or whatsoever. So my system here is an absolute non-inconsistent system. Regardless which number you try, they will not be solved. In terms of, for those who understand a little bit calculus 3, those are 3 planes in R3. And this is the situation when you have 3 planes that do not intersect. So having inconsistent is not something weird. It's 3 planes that do not intersect along anything. That's what's really happening geometrically. So the first rule that we have to learn is the following. Rule: if the echelon form of the augmented matrix of a system, so you start with a system, you have no idea what's really going on, you reduce it, and the augmented matrix has a row of the form. All the terms to the left are 0 except the one to the rightmost, the augmented term. So 0, 0, b, with b non-zero, then the system is inconsistent. And I write why. Because this row will read, will read the following: 0, x1 plus 0, x2. That's really what it reads. 0, xn equal to b. It means 0 equal to b, which is a non-zero term. That's inconsistency. So if the echelon form of the augmented matrix has a row of that form, immediately, the minute you see it, it means there is no solution for the system. Now, another way to state this is the following. If the rightmost column of the augmented matrix of a system is a pivot column, then the system is inconsistent. So it means you reach the augmented matrix. That's the augmented. And the echelon form of the augmented. What I'm saying that if the rightmost column, if this column has a pivot, it means has a leading. If this column has a leading, it means everything before it is a bunch of zeros. It means the system is inconsistent. All right, so we saw two examples. The first example, we saw example of a system. The first one I did that has one solution, which is 1, 4, 3. And now we saw another example of a system that have actually no solution whatsoever. Now we're going to take a system that have a lot of solutions. And the question is, how do we recognize that? But before I take up the system, let me a little bit give you some idea about what we're going to do. Suppose I take a very simple example. I suppose I tell you solve the following equation. Plus 2x2 equal to 3. Just one equation, not even two, one equation. All right, what do I mean by solving? Solving means you have to give me a way to read the solution without really having to think hard about it. So how can we solve the solution? How many solutions does this equation have? It's one equation, so a very simple scenario. All right, if I give you x2 to be 0, all right, that's one solution. If I give x2 to be 1, okay, then what is the solution? X1 plus 2 equal to 3, that's another solution. If I give x2 to be 2, I'll have x1 plus 4, then that's a third solution. So there are, what was the second rule? Okay, I read it again. It's the same one. It's not another rule. It's another way to state this. Is when you reach the echelon form, and if the last column of the echelon form is a pivot, it means it has a leading, then the system is inconsistent. Because if this row has, if you have a leading here in the last one, means so this is augmented. If this has a leading, it means everything up before it has to be 0. So this is really equivalent to say we have a row of the form 0, 0, and non-zero. Okay, that's really equivalent to that. So it's not a different rule, it's the same rule just written in a different form. Okay. So if I go back to here, every time I change the value of x2, I can get a new solution. So how we are going to write this? Okay, we're going to write this in the following way. We're going to say that x2 is a free variable. What does it mean free? It means x2 can take any value we want. But x1 is a constrained variable, or we will call it basic. It means x1 is constrained by x2. So x1 is free, always. I solve for x1 minus 2x2. And the way we will write the solution is like this, you know. The solution will be x2 could be anything. It means any variable, but x1 will be 3 minus 2x1, and the system have infinitely many solutions. What's the benefit of writing it like this? By writing it like this, I can give you solution as many as I want. I can give you x2 0, x1 3. x2, 1, I already solved for it. x1, 3 minus 2. x2, 15, x1, 3 minus 30. I can give you a lot of solutions. Right. This will basically prepare us for the following system. Now, my question is, let us solve the following system. Okay. Again, I'm still with 3 equations, 3 unknowns, and we're going to do. So I will do exactly what we always do. 1, 3, 1, minus 1, 2, 5, 1, minus 1, 1, 2, 0, 0. And I'm going to go to the echelon 4. So to the echelon 4. Very good. So let's see what I get. 1, 3, 1, minus 1. Minus 2 plus 2, it's a 0. Minus 6 plus 5, it's a minus 1. Minus 2 plus 1, it's a minus 1. And this is minus minus. It's give me a 2 minus 1, it's a 1. Minus 1 plus 1 is a 0. Minus 3 plus 2 is a minus 1. Minus 1, that's a minus 1. And minus minus, which give me a 1. This is guaranteed. So move to the right, move below. This is my leading. I'm going to use it to make this into a 0. So I do that, I will get 1. As I hope internet lasts me to the end of this lecture today. 0, minus 1, minus 1, 1, 0, 0, 0, 0. Am I right? I'm going to take the second row, multiply it by a negative, add it to the third, and this would be my new third. Minus minus is a 1, minus 1, 0. Minus minus is a 1, minus 1, 0. Minus 1 plus 1 equal to 0. Always the leading. Never forget the leading. Is this in echelon 4? Absolutely so. I have leading everything below 0, leading everything below to 0. The row of 0 is the end. Now I'm going to do one more step. I will not write it. I'm going to multiply this row, the second, by 1, negative 1, just because to make it a little bit simpler to do. Once I am in echelon 4, I write the system that corresponds to it. So immediately I write the system. So let's see what the system is. The first equation, x1 plus 3x2 plus x3 equal to minus 1. And the second one is x2 plus x3 equal to minus 1. So what does this mean? It means that every 3 numbers that make each one of those true, that satisfy each one, also will have to satisfy those 2, and vice versa. So those 2 systems are equivalent. Those operations we did do not affect the system. And now, what's the solution? I really haven't done much so far. So how we are going to solve the system? Let's see what's happening. Suppose I give x3 the value 0. So I give x3 the value 0. Okay. Can I find x2? x2 will be minus 1. If x3 is 0 and x2 minus 1, can I find x1? If I put 0 here and I put minus 1 here, so when I bring this minus 1 to the other side, it's going to be plus 2. So x1 is going to be 2. This is one solution to the system. I go and plug it here, it's going to be satisfied. 2. So this is the solution I found. So you guys see it, work with me. 2 minus 3 plus 0, that's a minus 1. 4 minus 5 minus 1. And then this is going to give me 2 minus 2 equal to 0. This will satisfy. If I give x3 another value, suppose I give it 1, I can find x2. If I know x3, I know x2, then I can find x1. So this is a system that has a lot of solutions. Every time I change the value of x3, I can find x2, and then I can find x3, x2, I can find x1. So how we are going to represent the solution of this? The way we will do it is like this. we are going to say that x3 will be a free variable. It means x3 can take any value I want. And then we will solve for x2 and x1 in terms of x3. That's how we are going to solve. But we need a little bit of terminology. So what we are going to do is we're going to call x3 free variable. We will call x1 and x2 basic variable. So x1 and x2 will be basic, x3 will be called free variable. Which one will be basic and which one will be free? The idea is the following. If the system is consistent, and in this case, there is no inconsistency because I have 0, 0, 0, and I have a 0 here, so I don't have inconsistency issue. In a consistent system, the variables that correspond to the columns with leading entry or the pivot columns are called basic variables. The variables that correspond to the column with no leading entry are called free variables. I keep this in front of you a little bit. So variable that correspond to the column with leading will be basic, the others will be free. Now, how do we describe the solution of the system? To describe the solution of the system, we use back substitution to express the basic variables in terms of the free variables only. That's how we represent the solution, right? So, okay, I'm just giving a minute for you to grasp. Free variable means the variable can take any value we choose. That is, every time we choose a different value, we're going to generate a general solution. Now I will apply this verbatim to our system. So right here. As I said, every time I change x3, I generate a new system. So now how are we going to write the solution? We will write the following. x3, we're going to choose it to be free variable. It means it can take any value we want. x1, x2 are the basic variable. So once the system is consistent, immediately the variables that correspond to the column with leading, those are, we call them basics, and those that correspond to the column without leading, we call them the free variable. Now I will express all the solutions in terms of the free variable. What do I mean by that? I mean the following. x3, I call it to be free, always. Then I need to solve for x2 in terms of x3. So I'm using back substitution. So I have x2 plus x3 equal -1. I need to solve for x2. Means x2 would be -1 minus x3. That's how we're going to write the solution. Now, I use the first equation to solve for x1 in terms of x3. That is going to give me that x1 equal -1 minus 3x2 minus x3. But this is not the solution. The solution should be so that all the basic should be expressed in terms of the free variable. It means I have now, by back substitution, substitute x3 by its value in terms of x3. So this will give me -1 minus 3 parentheses. Instead of x2, I have to substitute it. -1 minus x3 minus x3. That's how we're going to solve. And then we do a little bit of math, and I will get -1 minus minus, that's going to give me a 2. And here I will have -3 Okay, I will have minus minus plus 3x3 minus x3 plus 2x3. You can't take any stupid mistake I did right there. Okay, so that's how we're going to solve the system. So I rewrite the solution. So the solution so far is, and that's how we're going to represent it. x3 is free. x2 minus 1 minus x3, everything in terms of x. x1 is 2 plus 2x. And of the problem. Now, what's the benefit of that? Now, I asked, suppose I'm going to ask you, give me a solution of the system. You can give me very easily a lot of solution. So, if x3 is 0, minus 1, 2. That's a solution that corresponds to x3 equal to 0. Another solution, you can pick x3 to be 1. So I can have infinitely many. 1, minus 1, minus 1, minus 2, and 2 plus 2, which is going to give me the 4. So once I write the solution this way, I can generate a lot of solutions. So that's how we're going to solve the system. All right. Question number 2 is, we studied echelon form and we studied reduced echelon. And why we did that? So my second question is, suppose we have also a system. But this time, instead of stopping at the echelon form, I'm going to keep going to the reduced echelon form. And my question is, what's the benefit of doing this? So part 2 is, let's go to the reduced echelon form. Okay, because from echelon to reduced echelon form, we're only doing row operation, which will not affect the solution of the system. So let us do a little bit more operation. So I'm solving the same problem now. I'm not really changing anything, but instead of stopping at the echelon, I'm going to stop at the reduced echelon and then study the system after that. So I will do this. So I'm going to go to the reduced echelon. So this is I'll write it down and then I will pull the paper up. Minus 1, 0, 1, 1, minus 1, 0, 0, 0. So now this is my echelon. I'm going to go one more step to the reduced echelon and then we see what's going to be the benefit. So how do we go to the reduced? To go to the reduced, these are my leading. I start from the bottom one, use it to make a 0 above it. So to go to it, I have to take minus 3R1 plus R1, and this will be my new R1. This operation will not change the system. So this would give me the following. The bottom I'm not touching. 0, 1, 1, minus 1. And then the top would become minus 3 times 0, 0. Minus 3 plus 3 is 0. Minus 3 plus 1, it's a minus 2. Minus minus, that's a 3. 3 minus 1, it is 8. Now I am in reduced echelon. Okay? And now we're going to write the system that corresponds to it. And I'm going to do exactly what we did before. I say the basic variable, are the variable that correspond to the column with leading. Those are the basic. And then x3 is free. And I'm going to write the system that corresponds to my echelon form, which is x1 minus 2x3 equal to 2. And x2 plus x3 equal to minus 1. What's the benefit of doing this? And now we're going to solve. We solve in the same way. We solve by substituting. x3 is free. I'm not really touching it. What is x2? Minus 1 minus x3. What's the benefit of stopping at the reduced echelon form? Can anybody see the benefit? Can anybody see the benefit? What is x1? watch what's happening between this case and that case. If I stop at the echelon form, I still have a coefficient of x2 in here. So when I do back substitution, this coefficient of x2 has to be substituted by -1 minus x3. When I go to the reduced echelon form, I don't have a coefficient of x3 here, it's becoming 0. So I don't really actually have to do much in terms of back substitution. I will have the answer in much easier because there is no x2 in here, there is only the free variable. So the equation only involves the basic, one the basic and the free, one the other basic and the free. So we don't really have a back substitution, which will make the math a little bit easier. So x1 is going to be 2 plus 2x3, which is exactly what I got a minute ago, but sometimes the math will be a little bit easier. So whether to stop at the echelon or reduce is really a matter of taste. It's really up to you. If we stop at the reduced, at the echelon, we will have to do back substitution because the equation will involve the basic. If we don't stop at the echelon, and then we can express all the basic immediately in terms of the free variable. So we're going to do, of course, more problem along those lines. Okay, and this will be our last problem, which will make it very clear. So this is my system. It's a system of 3 equations and 4 unknowns. And if you want to solve the system by hand without using the techniques we're developing, good luck. So let's do that. How do we solve always? We start with the system. I write the augmented matrix. And I perform row operation. And this time I'm not going to perform them in front of you. You guys should do them on your own. And I'm going to stop at the echelon form, and then I go to the reduced. Then once I stop the echelon form, so that's my echelon, my leading, my leading. Okay, so how we solve the system? Step number 1 is we decide what are the basic and what are the free. The basic variable here are the variable that correspond to the column with the leading. So the basic variable here are going to be x1, x2. The free variable, and I will talk about that in a second, will be the variable that correspond to the column without leading. This one and that one. So we seem to have 2 of them, and now I'll explain why those 2. So the free is x3 and x4. Now, to be able to solve, I need to write the system that corresponds to my echelon form. I will write the system. What's the system? It's x1 minus 3x2 plus 4x3 minus 3x4 equal to 5. I have to write this. The second is x2 minus 2x3 plus 2x4 equal to minus 3. So solving this system is actually the same thing as solving that. It means every value, every 4 numbers satisfy this will satisfy those. But now, I mean, this is still complicated. I mean, if I tell you solve the system, you look me up and say, well, how am I supposed to do it? But let us analyze why we have 2 free variables here. Because watch here. If I give you a value of x4, you cannot find x2. There is no way to find x2. If I give you a value of x4 and a value of x3, 2 different values, then we can find x2. If I know x4 and I know x3, and I figured out x2 from this equation, then I can find x1. So that's why we need 2 free variables in this problem. We don't need only 1, because I need x4 and x3 to be able to find x2. So how we are going to write the solution in this case, all right? I will open it like that. And the way we're gonna write them is, you have to tell me what x1 is, what x2, what x3, what x4. All right, x4, free variable. What does it mean, free variable? free variable means x4 can take any value we want, any value. That's what x4 means. x3 is free. It means you can allow x3 to take any value you want. x2 is constrained. It's a basic variable. It's constrained by the value you assign to x4 and x3. So I need to express it in terms of x3 and x4. So now I take my second equation and I use it to find x2. So that's my second equation. Okay, so I want to solve for x2. So what is x2 in here? x2, sorry, what is x2? It's -3 plus 2, x3 minus 2x4. Okay, so I back substitute, find x2 in terms of x3. Now I still back substitute and I need to find x1 in terms of only the free variable. That's crucial. So what is x1? All right, I'll take the first equation and rewrite it. So that's the equation now. I use that to back substitute. So what is x1? It's a 5 plus the 3x2 minus 4x3 plus 3x4. And the question, do we stop at this stage? Yes or no? Anybody in the chat? Is this where we stop or we have to go further? No, absolutely not. What do we have to do? Everything has to be in terms of the free variable. But I have an x2 in here. That's not acceptable. So to solve, I need to do back substitution. So which is a little bit long, but that's okay for the first time. So instead of 3 now, instead of x2, I have to take this whole thing and substitute it for x2. That's how we solve. So that will give me, it's a -3 plus 2x3 minus 2x4 minus 4x4, plus 3x4. And now I have to do a little bit of math and finalize it. So finally I will get 5 from here, minus 9, give me a -4. That's where I start doing stupid mistake. And then what about x3? 3 times 2, that's a 6, minus 4, that's 2x3. And finally, -6 plus 3 minus 3x4. So that's what I'm having, granting I didn't do any trivial mistake or whatsoever. So what's the solution now? Let's rewrite the solution properly. So now the solution is x1 is -4 plus 2x3 minus 3x4, x2 minus 3 plus 2x3 minus 2x4, x3, x4 are free variable. x3 is free, take any value you want. x4 is free, it means to take any value you want. Now I tell you, give me a solution of the original system. The question at this stage is actually easy. Give me a solution. You just assign to your variable x3 and x4 any value you want and you start. So for example, if I give x4, for example, 0, let's be very, x3 0, then -3 minus 4. That's a solution. Or I can take 0 for here, 1, and then I will have another solution. So there are infinitely many of them, lots and lots and lots of them. Why we have? Because we have this free variable, and every time we change its value, we create a new system. Now, part 2 is, so we're done with this problem. But I'm going to push you. Let us stop at the reduced echelon form, so you can know the distinction between both. Okay, so instead of stopping here, let me go a step further and stop at the reduced echelon form, and let's see how will this affect the solution. This is 1 and this is 1. Stopping at the reduced, it means I make this into a 0. What will this do for us? As I said before, I won't have a coefficient of x2 here, or the coefficient will be 0. And then I will be immediately able to substitute, to solve for x1 in terms of x3 and x4. That's what the reduced echelon form will do for us. So let's do that here. So, and then, so the reduced echelon form. So 0, 1, minus 2, 2. And this is minus 3. So we're going to go to the reduced echelon form. Oh, thank you very much for letting me know. Very good. The last row hasn't changed at all. It's the first one. So I have to multiply by 3 and add. That's give me a 0. Minus 6 plus 4, minus 2. 3 times 2, that's a 6. Minus 3, that's a 3. And that's here I'm multiplying by a 3, which is going to give me minus 9 plus 5, which is a minus 4. So this is, and now I proceed as before exactly. I decide which are my basic, will be those variables that correspond to the leading. Though the free, it means the variable that can take any value I want. That's the benefit of them. Those will give me the infinitely many solution. And I write the system, crucial. I write the system that corresponds to that. My system would be, actually I'll write it here, x1 minus 2x3 plus 3x4 equal minus 4. And this gives me x2 minus 2x3 plus 2x4 equal to minus 3. And now I solve. This is not the solution. That's the system that which is easier to solve than the mess I gave you at the beginning. Now how are we going to write the solution? x1, x2, x3, x4. x4, anything I want. x3, anything I want. x1, x2 is constrained. So I'm using this equation to solve for x2. But that's easy. I have x3, I have x4. So this is minus 3 plus 2x3 minus 2x4. Now I went to the reduced echelon form, so the coefficient of the other basic variable is 0. So the other basic variable does not show up in this equation. So I don't need to do this back substitution. So x1 would be immediately, I solve for it. Minus 4 plus 2x3 minus 3x4. So this would be the solution of the system. And it's easy to read. I have a lot of solution once I write it like that. Not 1, not 2, not 3, infinitely. So that's how we are going to solve the system. From now till the end of the semester, actually in all your career, that's how you solve any system you have. You start with it, reduce it, and then once you get to the echelon form, go back to your system and interpret the solution. Okay, any questions before I proceed? Any questions? All right, I think I should talk a little bit more. All right, so let us a little bit, as you remember, I asked you to make copy of this worksheet. So we're gonna do a little bit of it. So I make sure that we all somehow understand what we're doing. Do you guys have the worksheet, yes or not?
Yeah.
Yeah,
Yes.
Let's go, one by one. In each of the following scenario, a system and its augmented matrix in echelon form is given to you. So I gave you the whole thing. The idea is how to do that. Decide if the system is inconsistent or consistent. In case it is consistent, decide whether the solution is unique. It means there is one of them, or infinite, means we have infinitely many, and then solve. Okay, the first system, that's the system. We reduce it, we get that. So that's it. The first one is very easy. Is the system consistent or inconsistent? Immediately.
Inconsistent.
Inconsistent. Immediately. When you see this row, It means, so this is inconsistent. Let us make sure we know exactly why. So that's inconsistent. Okay, because the last row, so the last row, this row read 0 equal 5/2, which cannot occur, which means that nothing can solve the system. So inconsistent because this row read, it means we have a row of the form 0, 0, 0, B, where B is non-zero. That's cause inconsistency. Now, problem number 2. Is the system consistent or inconsistent immediately?
Consistent.
Consistent, because I don't have the scenario. It means now, question number 2, is the solution unique? It means you have only one of them, or infinitely. It means a lot of them.
Unique.
Unique. Now, what really determines whether we have one or infinite? What causes the infinitely many solutions? What causes them is the existence of the free variable. It is a variable that can take infinitely many. That's really what causes them. And where this is usually come from, if I have a column from the coefficient part that not leading, that's really what causes free variable. All right, so this time everybody's telling me leading, unique, and I agree with them. Because if I write the system that corresponds to that, how would I write it? The first one?
X1 equals 29.
29. X2?
16.
16.
And X3 equals 3.
3. I have a unique, there is nothing else. There is no free variable. So the solution, at least for now, we're going to write it as a list of 3 numbers. Next, very soon, we're going to write it as a list of 3 numbers, but we're going to use a vector notation. But it's very simple. It's basically the same thing. Now, C. Again, my question is consistent, inconsistent, 2, 1 solution, or infinitely many. First, is it a consistent system?
Yes.
Yes.
Yes, there is nothing, 0, 0. All right, now, how many solutions we have? Watch what I'm doing all the time. I want this leading. How many solutions do we have here? 1 or infinite?
1.
Okay, 1, you're absolutely right. Because X1 is basic. Because there is a leading, and X2 is a basic variable. There is no variable that actually can take any value we want. So let me write the system that corresponds to that. What's the system? The first, 3x1 plus 4x2 equal -3. The second row read x2 equal to 3. So when I write the system, realize that really there is a unique solution. That's not a solution, that's just the system. So let us see what the solution is. X2 is determined. It's 3. There is nothing, really. That's it. X1, I can totally find it from the first. So what is X1? So I have 3x1 is -3 minus 4x2. It means it's -3 minus, 3 times 4 is -12. It means -15, but that's at 3x1. So this will give me x1 is -5, right? Am I right? And x2 equal to 3. So the solution to my system is -5 and 3. Now we can check. Are those equations satisfied? Let me try the last one. Minus, let's give me a 10. -9, that's 1. Absolutely right. And then you can back up and make sure. Geometrically, what does the system represent? What does the system represent? Who can think a little bit in geometrically?
Intersection of 2 lines.
Not 2. No, I disagree. That's the intersection of how many lines? Three equations. It means you have 3 lines. The line given by this equation, the line given by that equation, and the line given by this equation. So this is actually the intersection of 3 lines in R2. And that's our intersection point. All right. Now, D. Is the system consistent first or inconsistent? And then we proceed. 0, 0, so that's consistent. Immediately, I go after the leading. All right. Now my question is, does it have one solution or infinitely many? Back to you. What do you think?
Infinite.
Infinite. What's gonna cause the infinite is that x3 in this problem and x4 are going to be free variable. In other words, before I solve, let me convince you one more time what's really happening. There is no leading here. So this is going to read, the first one will read x1 minus 3x2 plus 4x3 minus 3x4 equal to 5. And this would read x2 minus 2x3 plus 2x4 equal to minus 3. So now what's going to happen that every time you give x4 and x3 a different value, you can come up with a value of x2. And then once you have x4, x3, x2, you can find x1. So that's really causing that we have a lot of different solutions. So whenever one of the variable is free, it means whenever one of the columns doesn't have a leading, the variable that corresponds to this column will be free. And that's give me an infinite many solution. Now let us solve. That's not the solution, that's last interpretation of the system. Let us solve. You can either start solving from here, or you can go to the reduced echelon form. What would you like to do quickly? Would you like to go to the reduced echelon form or stop? It's your choice.
We could just solve in the echelon form.
We can solve with the echelon. We can solve. So let us do it. x3, free. I would go to the reduced, but since that was your choice, I will go on with it. x4, free. x2 is, I will use this equation to get x2. It's minus 3 plus 2x3 minus 2x4. I expressed x2 in terms of x3 and x4. x1. What is x1? I use this equation to solve for x1. But it's going to be a little bit of math because this equation, since we stopped at the echelon form, the coefficient of x2 is not 0. So I have to substitute x2 by its value, but that's all right. So it's going to be a 5 plus 3x2 minus 4x3 plus 3x4. But this is not a solution. This is not the way we write the solution. To write it, everything in terms of the free variable. It means I have to go on here. So this will become 5 plus 3. Instead of x2, I have to substitute x2 by its value, which could be minus 3 plus 2x3 minus 2x4. I have to. And then minus 4x3 plus 3x4. And finally, I just have to connect stuff. So minus 9 plus 4, that's a minus 4. And then I have 3 times 2, that's a 6. 6 minus 4. And then minus 6 plus 3 minus 3x4. Give and take a stupid mistake. And that's what the solution is. Everything in terms of the free variable. Now, if I tell you, give me a particular solution, you can give me tons of them. Every time you assign to x3 and x4 different values, you generate a different solution. That's where all the solutions are coming from. All right? So that's how we are going to solve the system. Okay. Again, number 2. We did the problem. We still have a few minutes, and we proceed. The idea here is to tell you that how by just looking at the echelon, you should be able to tell what's the type of the solution. And that's really the importance of it. The echelon tells you everything almost you want to know. So each of the matrix below is the augmented matrix of a system after it's being reduced. So I have a system in my mind, I reduce it, I get something like that. And by now we know what stars represent. Stars represent non-zero numbers. And now it is my question, are the system consistent or inconsistent? If it's consistent, do we have a lot of solution or only one? Very good. The first one, immediately, by now I think everybody knows, 0, 0, 0. First I put the leading because this is really helping me. Leading here, and this leading is right here. So the leading is in the last row of the augmented matrix, in the rightmost. That immediately tells me that I have inconsistent. So inconsistent because the last row reads 0, 0, 0, B, where B is non-zero. This reads 0 equal a non-zero number, which is giving me the inconsistency. Okay, problem number 2. The question again, consistent, inconsistent, unique, or infinite?
Consistent.
Consistent, yes, because let me go after the leading. These are the leading. There is none in the last column, in the rightmost column. There is none in the augmented column. So there is no issues like this. All right, is it unique or infinite? How many solutions do we have? First, how many variables do we have? How many variables? Quickly. 3. And we had 4 equations initially with 3 variables. All right, so how many solutions do we have?
1.
Yeah, 1.
1? Do you agree? Okay, let us first analyze why is 1 and then how we know just by looking at it. All right, the last column, sorry, the last row will give me x3 equal to something, whatever the number is. So I know x3, that is not a free variable, it's very well defined. So x3 is fixed. What about x2? Is it a number or it's x3 is fixed because whatever this number is, so I know what x3 is, it's not free. So I know x3, which is a fixed number, x2 will be fixed number, x3 and x2 are fixed, x1 is fixed. So there is no room for a free variable. Now, by looking at it, you ask yourself, if you know what you want to know whether that is free, is there a column to the left of the last one that has no free variable, that has no leading? No, this has a leading, a leading, a leading. It means each one of them is basic. Each one of them have a very specific value attached to it. So here there is unique because there is no free variable. Every column left to the last one, left to the last column has a leading. So every column left to the last one has a leading entry. Okay. So immediately by looking at it. Now, because we're almost done, what about the last one? Consistent or inconsistent? Quickly.
Consistent.
Consistent. Because I go after the leading. There is no leading here. There is no 0, 0, 0, non-zero. Is it unique or infinite?
Infinite.
Infinite. Why it is infinite? Very quickly.
X2 will end up being free.
X2 will be free, exactly. What is the value of X3? My apology. 1, 2, 3, 4. That's for unknown. What's the X4 in this problem?
0.
Absolutely. X3 is very determined. Once I know this number and I know that, I know X3. What's going to be free variable is the X2. We're going to have infinitely many solutions. So that's infinite infinite because x2 will be free. Every time I change the value of x2, I'll generate a different value for x1. So x3 and x4 are going to be fixed, but x1 will change with x2. Every time you give x2 a value, x1 will generate another value. Okay, so that's it for today. As you guys know, Thursday will be your first quiz. It will cover everything we've done so far, including what I did today. It's crucial. So you have to know the vocab. You have to know how to go to the echelon, the juice echelon form. You have to know how to solve the system and how to write it properly, x1, x2, x3, how to recognize it's infinite, how to recognize it is unique, and so on and so forth. Another thing about the quiz, the way you will have to upload it to me is that I want it as a PDF document, because some students, you know, they take a picture using their iPhone. Brightspace will not give me a good format. It's hard for me to download it, upload it into download from Brightspace. So I would like a PDF document. So figure out how you can upload a PDF document for the quiz. You should be able to figure this out. And if you have difficulties, let me know. And there is an app that you can put on your phone or on your computer that you can, you know, everything could become a PDF document.
You said the quiz is Thursday?
No, not Thursday. I meant Wednesday.
Okay, good. Thanks.
Yeah, I'm sorry. It's going to be Wednesday because I always start linear algebra on a Thursday. That's the first time I teach on a Wednesday. So Wednesday is your first quiz. It will be at the end of the hour. So right in front of me, you go to your computer, and I will explain that on Wednesday. You will take the quiz, you write on a nice piece of paper, you transform it to a PDF document, you upload it into Brightspace. And we will do that this Thursday, so you will get into the habit of doing it. Any other questions? Anything you guys want? Any questions?
I have a question.
What?
Will we email you the PDF, or will you create a Dropbox on Brightspace so we turn it
On
in?
Brightspace, everything on Brightspace.
Okay.
Yes, it will be next time before you guys take the quiz. I'll take 2 minutes to show you. No email. No, there are so many students. It will be confusing. I want everything uploaded into Brightspace. Is that clear? I mean,
Yeah.
all right. Any other questions? Okay, please do the homework and review everything we did. And do we have to scan the quiz? No, you don't have to print it. It's up to you. But you have either to scan it as a PDF document, or if you take pictures of it, use some kind of an app that will transform the picture into a PDF. Otherwise, it's hard for me to read every possible document. But you don't have to print. It's up to you. Okay, anything else? All right, I will put the homework on Blackboard, on Brightspace, and if you have questions, my office hours are open for you guys. Good luck. Bye.